Okay, so this is a quick demo of the Dronedesk SORA functionality. So I'll create a job. As a first step, to select a SORA type operation. So let's say we're going to do VLOS. If you don't select SORA, then the SORA tools won't be available on the job. Select the client. Okay, so once we're in the job, you'll see the SORA flight geography calculator. So this is the first step. The system's picked up which drone you've selected for the job with the available parameters. You can modify these if you want to. So if you've got an argument that says you can reduce the max speed from the manufacturer's published maximum, then you can do that. So if we start to reduce it, you'll see you'll be required to provide justification for that. So throughout this process, Dronedesk will prompt you for justification where you differ from the standard entries, and that's simply there to ensure that you provide that justification up front and avoid having to have a to and fro conversation with the CAA about those justifications. So provide it here, otherwise you'll be asked to provide it anyway by the CAA. So you can go through and select the appropriate contingency maneuvers, vertical and lateral, and the GRB, ground risk buffer termination method. You can specify the altitude errors, the GPS inaccuracy, and again for all of these there's a suggested value, and if you go below those you'll be prompted for justification. Flight geography, flight height will be automatically calculated based on a max top ceiling of 120 meters, as will the VLOS distance. So once you've configured this, you can click recalc, and that will generate the final numbers for your configuration. You're still able to modify these numbers if you want to. So if you have an agreement for a different lateral value, if you agreed a 50 meter, then you can enter that for sure. But again, you'll be prompted for justification. So again, you need to enter that justification, then click save. So those new figures will be overlaid on the image below, and then transposed to the site plan. So if we now go to the site plan, let's say we're going to do an inspection of this rail line. So what we can do here is create a corridor using the corridor tool. It will prompt me for the corridor width, so you can set that whatever you want to, and then create the corridor. So as soon as I create that, the system will perform the population density calculations. So 3 metrics are generated or calculated. That's the people count, so that's the entirety of the number of people within the FG and CV. The max density, which is the important one really for your application, so that'll be the max density within the FG, CV and GRB, and then it will also calculate the average density within your adjacent area or adjacent volume as it's referred to in Dronedesk. So that's given us an initial GRC of 5. So I can zoom out just to show you the extent of the adjacent volume that's been included here. I can edit this. So I've noticed actually the path is slightly off the rail track, so we'll just move that slightly just for completeness. Save. And as soon as you make any changes like that, the system will recognise the fact that you've moved or changed the shape or size of the or position of the flight geography. So when I click on it now, you'll see a recalculate button, and that's persisted across sessions. So if you've edited the flight geography and not done the recalculation, the system will recognise that fact. So if I refresh that page, you'll see it now does an automatic recalculation based on the new shape or size or position of the flight geography. So if I click on it now, you'll see it's been calculated. So we've got the population details. So those metrics are reflected down here. We're still GRC 5. Just to mention, because I've used the corridor tool, I do have the option to split this corridor. So we are, let's look, we can split this. So if you want to split it into 500 meter lengths, you can do that. And then the system will calculate the population metrics for each of the 500 meter sections. So any of these I click on will now show its own individual metrics. Okay, so just for clarity for this demonstration, I'm going to remove that and redraw. And again, every time you drop a flight geography, you'll get a recalculation. So assuming I'm happy with that, I can now go through my assessment. So if I click on assess, that will pop up the window that allows me to go through the process. So the population density information metrics are redisplayed here. So if I have a different view of what the population count, max or average density is, then I have the opportunity here to override those numbers. But again, I'll be prompted for justification for providing alternate numbers here. Possible assemblies of people. This will look for possible assemblies of people within a kilometre radius outside of the CV outer boundary. In this instance, it hasn't found any, so that's fine. If it did find any, then it would list them here. And again, you'd be mandated to provide some comments on those assemblies of people. And that might be to explain mitigations, or it might be to explain the fact that it's, I don't know, a sports venue that's only occupied on a Saturday afternoon, for example. So then clicking on the ground risk tab, I now have the available ground risk mitigations listed here. So I can elect to implement any of these mitigations. So let's say we're going to implement sheltering. I will be required now, because I've selected that, to provide justification. So operational restrictions, ground observation. So again, I'm going to implement that. So that's getting us down to GRC 3. And we'll leave it at that for ground risk. Actually, no, let's implement operational restrictions as well, just for demo purposes. So I'll apply that. Just for demo purposes. And then we come to air risk. So this will walk me through a textual representation of the flowchart that you'll see in Article 11. So I can say this is atypical. And again, I'll be required to provide justification if I'm saying this operation is in atypical airspace. If not, I'll need to select the airspace class. The system will automatically identify the airspace class, and it will also list other airspace that's at the centre of the location that we've elected. At the centre of the location that we've drawn. I can say I'm going to implement VLOS, and again I'll be required to provide justification, so I can select whether that's direct airspace observer or UA observer. So let's say airspace, and again I'll need to provide justification. We do list strategic mitigations, but the note, as per the note here, those do not automatically reduce the residual ARC score, but you can still elect to implement them by clicking and providing justification. So that will be transposed into the report that you're able to generate, and that will generate or trigger the conversation with the CAA about whether or not that will reduce your ARC. Just on the airspace class, if I'd have selected a different value, then I'd have had the system would have presented the available options, and again, selecting any of these will trigger the next step, depending on the scores I select or the options I select. And at every point, you'll be required to specify the justification. If, as in this case, it's kind of removed the justification that I provided for my VLOS because I changed the airspace class, then you'll see restore previous entry, so that will pull back any entry that you'd previously entered in originally. So we're at ARC B, ground risk 2, so that's given us a sail 2 score. So I can now click apply, and that's locked in. So that assessment is now locked into this job. So I can now click report, and that will generate the report that I can now submit as part of my application and or as proof of my compliance with my authorization if I've already got a SORA approval. So the assessment is pretty comprehensive. The report is pretty comprehensive in that it contains operator details, US details, details about the operation, the flight geography calculations. So anything in blue is what you've entered. So that it provides easy reference for CAA to see what you've entered in the system. We've got contingency volume, ground risk buffer, and so on, so forth, the full extent of the calculations that have been performed, along with any justifications if you modified any values, the plan of the showing the volumes, the flight geography geometry, along with any corridor waypoints, the flight plan map. Actually, I'm going to just close that for a second and go back to my tools just to indicate where the pilot location is going to be. So you'll notice as I move the pilot around, the max EV boundary is shown. So this will indicate whether or not this is a BVLOS operation or line of sight. So just for demonstration purposes, I'm going to put the pilot at that location. Actually, I'll show a couple of pilot locations just for demo. So now when I click the report, you'll see that the pilot locations are also shown on the map because the CAA will want to see the pilot locations. The report also includes the KML export, so the CAA are able to replicate exactly your flight plan. We've got the population analysis, so max population density, any information about the assemblies of people, and then the ground risk assessment, so characteristic dimensions, speed for the drone, and what population density iGRC was assessed. Then you've got the mitigations and your justifications if you selected any, and then the final GRC. Then it moves on to the air risk assessment. So the selections that you've made in there, along with the strategic mitigations, but just to reiterate, this doesn't automatically reduce your ARC score. But we implemented VLOS tactical mitigation there, which is justified here, and that's taken us down to Hog B. So that's given us our final sale of sale 2. And then the appendices talk through all of the calculation methodology, how it's arrived at, the technical details of the calculations, information about the kernel density calculation. With this is an important nuance in the UK SORA, in that Dronedesk uses JARUS SORA 2.5 Annex F 3.9.1, which in essence uses a sliding kernel approach to calculating the max density, and provides a more accurate and fair assessment of the max density. So that method's been reviewed and confirmed as accurate by the CAA, so you've got a kind of head start in terms of getting that through approval. Then we've got average density. We've got information about the data sources that have been used and the query parameters, so anybody can replicate what we've done in Dronedesk. And then we've got the per cell audit data. So this will only show the first 50 cells actually, for each of the calculations. If you need to submit all of the data for those calculations, you can do that, and I'll show you that in a second. So assuming you're happy with everything in here, you can just click print report. That'll get you a print window, so you can export that to save it as PDF and export it. So that's your SORA assessment report complete. If you need, as I mentioned, the full details for any of the metrics, so you can get the count per cell data, the max cell data, and the average, click on those and you'll immediately get a download with all of the data required to prove your the accuracy of your calculations. So that's cell by cell breakdown of the entire calculation. So that's it. That's a quick run through of the SORA functionality for UK SORA in Dronedesk.